We're going to find the LCM by listing the multiples. Remember, LCM stands for the least, the smallest common multiple that two or more numbers share. Remember, multiples are the answers to multiplication problems. Let's start by listing the first 5 multiples of 10. 10 times 0 is 0. 10 times 1 is 10. 10 times 2 is 20. 10 times 3 is 30. 10 times 4 is 40. Now let's list the first 5 multiples of 8. 8 times 0 is 0. 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. 8 times 4 is 32. Let's stop. Do we have a common multiple yet? Now you might say, Miss Kluber, yeah, we do. Look, 0 and 0, and that is clearly the smallest. Well, 6th graders, my response to that is 0 is a multiple of every number. So when it comes to finding the LCM, 0 doesn't count. It's still important to list 0 as a multiple, but it doesn't count for the smallest multiple that numbers will share, since 0 is a multiple of every number. So as you can see from our list, we don't have a common multiple yet. Let's keep going. Let's list maybe 2 more multiples of 10 here. So we have, oopsies, 10 times 5 is 50. 10 times 6 is 60. Let's go ahead and let's list a few more multiples of 8. 8 times 5 is 40. 8 times 6 is 48. Let's stop and look at our list again. Now do we have a common multiple? We sure do. They have 40 in common, and you can see so far that it is the smallest multiple that 10 and 8 share. So therefore, the least common multiple of 10 and 8 is 40.
All right, ladies and gentlemen, now let's use prime factorization, factor tree, to find the LCM. This is the third chunk of your notes. Let's look at problem number 1 here. Find the LCM of 35 and 45 using prime factorization, factor tree. I'm going to read the steps. You now need to turn to the back of your notes and follow along as I read the steps. Our goal is to find the LCM of 45 and 35. So the first thing we need to do is factor each number. So 35 and 45. Let's factor each number down to a product of its primes. So I have 5 times 7. They are both prime. My prime factorization is 5 times 7. Break 45 up into 5 times 9. Break 9 up into 3 times 3. My prime factorization is 3 times 3 times 5. Now I'm going to use this. The next step says write the prime factorization. That's what I did. Now I'm going to use the prime factorization to first find the GCF using a Venn diagram. Just like we did in our 4-4 notes. So this circle will go with 35. This circle will go with 45. So let's first start by finding the greatest common factor of 35 and 45. What do they share? They both share a 5. That's a common prime between 35 and 45. Do they share anything else? No, they do not. So we're going to place the remaining primes in the circles. This is step 4 in your notes, just like we did when we were finding GCF. There's a 7 that remains with 35, and there are 2 3s that remain with 45. The last step says multiply all the prime numbers together. So we're going to multiply all the numbers together. 7 times 5 times 3 times 3. When you multiply all of those values together, you get the LCM, which is 315. So here's an example of how you use a Venn diagram with prime factorization, factor tree, to find the LCM. Make sure you have all of this down in your notes. We'll see you later.